I'm really happy to be here today to introduce you all to Nolan Manteufel, who I met through some comments on my channel. His comments were very intriguing, and I couldn't quite understand them. So I thought, well, it'd be good to talk to him and have him explain them to me. And Nolan, I'm going to let you introduce yourself. I know you're an electrical engineer and you work on the printed circuit board aspect of engineering. And maybe you could talk a little bit about how you came to do that, like maybe how you grew up and what led you into that field, and then what got you interested in the channel and commenting on the channel, and sort of take it from there.
Okay. Well, first of all, thank you for inviting me on as a guest. And I've actually just had a little bit of nervousness right now being introduced. So I just want to let you know I'm very grateful to be here. And
well, I'm really happy that you're willing to come and talk, because I always learn so much from the people that are watching the channel.
Yeah. So a little bit about myself. So I'm an electrical engineer. What I love about electrical engineering is a little bit outdated. It's the circuits that were kind of the golden era in the 70s, 80s, and 90s. That was what I read as a kid. And so designing circuits with ICs is something that I find comes naturally to me, at least in an intuitive sense.
IC is the integrated circuit?
Yeah, integrated circuits. And
my husband was a chip guy for many years.
Really?
Yeah,
okay.
Yeah.
So he got to design them?
No, he was in marketing, but he worked for many years. Well, he worked for many years in telecom, and then networking and routing, and then chips. And now he's on the Wi-Fi end of things. But I've heard the terminology my whole life. So
yeah,
ASICs and IC and all that kind of stuff. Yeah.
Interesting. So first of all, like out in California, Silicon Valley, I know there's a lot of marketing people in the semiconductor space. But the story that came to mind when you mentioned that was the 555 timer wouldn't exist unless it was first embraced by the marketing person that it was pitched to. So that's a long story. Anyways, but yeah, so yeah, okay, cool. Anyways, yeah, so a little bit about myself. Electrical engineer. I was introduced to electronics at like age 14. And so I just read a bunch of stuff from the library and anything I could get my hands on. That was before the internet for myself. So it was all through books and magazines. Yeah, and so I just pay attention and read a lot of stuff and spend hours listening to conversations on YouTube, seeing what people are talking about these days, and then met a couple people through the comment section, and then one of them showed me some of your videos, and I found them very intriguing. And then I read the about section on your channel, and I just really enjoyed it. I was like, wow, and more, because it lists your interests. And it's not very often that you find someone with philosophical interests, scientific interests, and then also like artistic interests. Yeah, but man, I'm a little starstruck. Sorry,
a little nervous. That's so funny. I'm just an ordinary person. I'm just an ordinary person. When I started this channel, I started it at the kind of recommendation of Paul Vanderklay. I don't know if you've run into his work at all. He got started in YouTube about 5 years ago, maybe, when he got interested in Jordan Peterson. And so he started making videos about Jordan Peterson. And I was interested in Jordan Peterson at the same time, and I ran into Paul's stuff. And so then I was on Paul's channel one time, and then he said, why don't you start a channel? He said, anybody can start a channel. So
Mhm.
so I asked my daughter, who at the time was like 23 or something, and she was really into all this stuff. I said, help me start a channel. So she got me set up, and that's it. I'm just an ordinary person. I have had the extraordinary opportunity to talk to a lot of very, very interesting people, but I'm just an ordinary person. So no need to be starstruck.
Oh,
But
well,
but I want to go back to what you said about when you're 14, you started reading books on electronics, and
yeah.
then that got you interested in electrical engineering. So you went to college. Somewhere along the line, you also developed an interest in philosophy and art. So how did that happen?
Oh, okay. Well, so my parents decided to homeschool my siblings and I around 1999, 98, 99. And I was going into sixth grade.
Mhm.
So, so from sixth grade through the end of high school, my education was pretty much self-administered. My parents would slide a stack of textbooks across the table maybe once a year and say, you should go through these in the next year.
That was your homeschooling?
So that was the homeschooling.
Wow.
And
Wow.
in Texas, there's no requirements on academic um, integrity is the wrong word, rigor,
Uh-huh.
maybe. Um, so so a couple of years in, Dad was like, I want to make sure y'all are learning something. So he had us take the SAT, you know. And so it's like, okay, cool. But other than that, there was like no feedback on if I was actually learning anything. So I was really just learning the things that I wanted to learn, which was math and electronics.
Well, obviously, in order to do
And
that, you had to learn to read well and to think and all of those things. Otherwise, you wouldn't have been able to learn math and electronics, right?
right, right. Well, I did have a fifth grade level
Yeah.
of spelling and reading. But I didn't read any Shakespeare. I didn't, you know, if I wasn't interested in it, I didn't go pursue it.
So
And
this is a personal question, which you don't have to answer, but some
sure.
people might say they feel a lack because of things that they missed out on. Do you feel that you missed out on something, or do you feel it was a great
Um,
benefit to you to be able
I
to pursue your interests?
I've hyper analyzed it, and I'm not sure. I would say yes, but maybe in ways people don't expect, or maybe in ways they do expect, but the way I would phrase it or the perspective might be different than they would expect. Um, so, and then a lot of it may just be, you know, myself and like how I process things. Because
Yeah.
you could take two different people, put them in the same situation, and they'll experience it differently.
Yeah.
Um, so, so in an educational environment where I'm kind of left alone um, to pursue things, I find things and I pursue them. Whereas maybe some people wouldn't be the same way. So yeah, so I would say there are downsides to being educated um, outside of a classroom,
Mhm.
um, and um, and so those are just stuff you'd have to consider on a case by case basis with the people you're looking at or talking to.
Mhm.
Um, so, but I
Yeah.
don't
Well,
know. I'm very
I homeschooled my older daughter um, when she went into starting from seventh grade. But we had a pretty rigorous curriculum that was developed that had the whole thing laid out. But what she did was she took a look at the whole curriculum before she started, and it was 6-year curriculum. She said, I think I can do this in 5 years. And so she just set herself the task of finishing it in 5 years or 4.5 years. So that got her motivated to work really, really hard so it wouldn't take her so long. So
wow. Wow.
But she often felt that she missed out because she didn't get a lot of rigorous science because it was mostly from the book. There wasn't any lab work, right? Part of that was because we were traveling a lot as getting prepared as missionaries to go overseas. And so we were on the road quite a bit.
Hmm.
But I felt like she did see some lack in what she got out of that. But there are advantages to homeschooling too, because you can do field trips, you can spend time with people who are expert in the things that you're interested in, and all of that.
Absolutely. Yeah, you have more control over your environment and your opportunities. One of the things, as I'm in my mid 30s, so I've been able to process it as an adult for a while. One of the things I've recently realized is if I think back to first to fifth grade, I can remember things that I learned last in the class, right? So when it came to spelling words for the first time in first grade, I was like the last one in the classroom to kind of learn the spellings of certain words. I was playing a different game with the alphabet. It was up there in the top of the room, I was playing a different game with it. And everybody else was spelling words, and I was like the last one to catch on to that game. And that kind of was a consistent pattern of kind of activity in the classroom. I think I was the last one to learn the game everybody else was playing. And so from sixth grade through 12th grade, like that's a lot of catching up to people that never happened. So that may be my secret talent, I guess, is just thinking in a different way, perhaps.
Yeah, well, I can
Yeah.
see why homeschooling would be really good for somebody like you, because that's the kind of a mind like someone like Einstein has, where they're just completely thinking about a different kind of world. And in our world, you get in trouble for that, right? I mean, I remember getting my knuckles rapped. I'm from back in the day when the teacher had a triangular ruler and they'd come around with that and smack your knuckles because they wanted you to be listening. And my mind was off somewhere else. I was thinking about all kinds of things.
Yeah.
Yeah.
One time, the teacher sent a note home to my parents saying I didn't know how to read, and I forget what grade I was in. And my parents decided to test it, right? So like, hey, Nolan, you know how to read, right? I was like, yeah, I know how to read. And they're like, can you read out of this book right here? And it's like there's a storybook about a dog or something, and it was kind of a boring story, so I started making up a story that kind of followed the line of the. And they're like, no, read what it says. And so I like forced myself to read what it said. And they're like, yeah, see, he knows how to read. So yeah. But anyways, so anyways, a lot of childhood stuff that could be thought of and analyzed and hyperanalyzed. In 2012, I came up with a joke. It was, or maybe it's 2013, but basically, if someone says that you're over analyzing the situation, what that means is there's an appropriate amount of analysis. And what that means is you should be able to measure analysis as it's exerted over time or on a problem. And you should be able to catalog or build a memory of all the analysis that has been exerted for given problems. And then you should be able to compare different problems and then come up with like an appropriate amount of analysis for a particular problem. And then you should be able to observe analysis being exerted on pretty much all problems and come up with evaluations, which are over analysis, under analysis, proper analysis.
Yeah. Yeah.
isn't that? Yeah, and
Yeah.
all, and that
Well,
was
and
that
the
was
thing that the reason that jumps out at me is that Jordan Peterson is always making the statement when somebody says some stupid thing, he'll say they're approaching it from the wrong level of analysis. Now, he doesn't mean over or under, but he means there are appropriate levels at which to analyze things. You have to analyze things in the right category for a certain purpose, that there are purposes for analysis, and you can't just have scattershot analysis and then come up with some idea and think that it fits in a particular situation, because there's got to be a context for it, right? So for you analyzing yourself, that's a very personal context. I don't see how anybody could ever say to you, well, that's over or under. You know?
right, right.
But I mean, we can get ourselves all tangled up. So I mean, maybe that's what they meant by over analysis, that you were yourself kind of tangled up.
Right.
I mean, I can certainly do that about myself, get tangled up in stuff, but
yeah. Huh.
yeah, I like that because what the picture that you just drew about, you should be able to make this kind of matrix of appropriate levels over and under and all that. I sort of see the whole world operating that way. Like, one of the things I'm interested in is, as everybody knows, I'm beating this dead horse, is Michael Levin and his work with cells and biology. And these cells are first of all, I mean, I think it's such a miracle that cells differentiate. You start out with all these cells the same, and then they differentiate out into heart cells and skin cells and, lung cells and whatever. That's amazing. But once they differentiate, then they have to build the thing that they are made to build. Well, it's sort of like they're searching some sort of possibility space to find out, to make this thing. There has to be something over and under that's a space like that they're searching inside of. In the same way that when you're trying to think your way through something, there's some sort of a structure inside your head that's built out of all of your past experiences and all of your reading and all of your friendships and everything. And you're searching that possibility space to connect things together, right? I sort of think the whole world is built that way.
Yeah. Yeah. Okay. First of all, I agree. And then the next thing to kind of touch on is I think what made separate your brilliant philosophers from your average is the brilliant will know when to stop asking questions and just feel comfortable not knowing.
Mm-hmm.
And maybe create a game or a story at the level that they understand, and then proceed from that game.
Mm-hmm.
And since my background is electrical, I actually took no biology or chemistry classes before college. So I can't speak with any certainty even about cells or how they behave. But anyways, all that to say, electricity and electronics, magnetism, the game, I think most of it is based on a game of flow equals conductivity times potential, which is just I think it's, anyways. Boy, that's hard to, sorry, that's too far out. But yeah, so Michael Levin's work in biology, cells, knowing what the overall plan is.
Well, so I mean, his work in biology is irrelevant to the idea that I'm trying to understand that's inside my head, because even though I had biology in high school and in college, in my undergraduate work, it wasn't for a major or anything. It was just a general thing. And I think my education was really so poor that I didn't learn much of anything. So anything at all that I know about biology, I got from helping my daughters when they were going through school, or
Yeah.
from watching YouTube videos
Yeah.
voraciously for the last 5 years. I mean, there's a lot to be gotten from that, but there's so much inside any one of these fields. If you even take just one little portion of a field, and then if you do a deep dive, there's an endless amount of stuff that you can spend your life learning, right? So
so I do have an elaborate kind of view of looking at stuff that is very useful in thinking through stuff that like Michael Levin talks about. At least it's useful for myself. But it's all just based on a game that I start at an imaginary level with a source, a conductor, and a flow through the conductor due to the source, which is natural to me because of electricity and
okay, so let me feed that
magnetism.
back to you. A source,
Sure.
a conductor, and a
Yep.
flow
Correct.
that flows through the conductor because of the source.
Yes, that's correct. And that's the game I feel like scientists and engineers have been playing with electricity and magnetism at least since Ohm. So for a while. And I honestly think it's just a game.
So when you use the word game, what do you mean by that?
I mean, if you ask further questions, you're going to come up with a I don't really know. And so you get to choose whether or not you want to play the game or not. It's not mandatory.
Oh, so like when somebody starts talking about gravity, and gravity obeys these certain laws and you can measure it this way and blah, blah, blah. And then you say, what is gravity? And they say, I don't really know. I just know it functions this way. Kind of like that.
Absolutely. Yeah.
Okay.
So for electricity, it's all the electron, right? The electron and its motion. And then when you ask, well, why does the electron move? You say, well, you know, like, because and there's a bunch of different situations where an electron can move, right? In a solar panel, a light will hit the semiconductor that's, you know, junctioned with another one, and they got different concentrations of electrons on this one than that one, and the way that the energy hits and it pushes it. Right? And it causes a flow at the junction, right? So there's a bunch of different reasons, but at the end of the day, it's an electron flowing through a conductor due to a source potential, right? And I really don't know if it goes any more scientific than that game that everybody's just accepted to play.
So
like, why does it move?
Is the source potential always something that can be measured, like light? I mean, light can be measured. Is the source potential in this game always something that can be measured?
I believe all objects in the game can be measured. So you can count electrons, and you can measure space, and you can measure time. And so you can effectively count how many are moving how fast over time. And then you can count how many are here versus how many are here versus how many are here. And then voltage is simply the difference between counts as a ratio of the distance between the counts, right? So you can basically count and measure pretty much every element or parameter we're talking about. But if you ask why, right? Like, why does it behaves certain ways. And I think that's where the engineers stop asking those questions, and they just go, "We got it. It's this is the equation. This is how it functions. We can use this. We can build a machine. We can build a higher complexity circuit using what we know, and for us, that's enough." And so what I've done over the past 10 years, so it started in 2012. I was a bad student, right? It started all because I was a bad student. A professor assigned a task that was boring to me. So I just decided it's for extra credit. I'm not going to do it. I don't need the extra credit. It's kind of boring. And my roommate, who was also my classmate, we were walking the campus. It was like a 12-minute walk. And he's like, "Man, you should just do it. It's super easy. You just sit down and do it." It's like, I know how to do it, but I just didn't want to, right? And since I didn't want to, I felt like I couldn't. And so what I described to my my roommate was that it's like Hooke's law, but for people. So Hooke's law says the force a spring is exerting is equal to the spring's capability, spring's stiffness, multiplied by the amount that it's stretched or compressed. And so I abstracted from that and said, it's like the force I can exert to do the assignment is equal to how much I'm able to do the assignment, which he was pointing out I was able, times how much I want to do the assignment. And since I don't want to, I feel like while I'm able, the force I have to exert is zero because I don't want to. So in 2012, I came up with this explanation for a roommate on why I'm not doing my homework, right? I'm a bad student. It's really no more complex than that. I'm just a bad student, right? But I made up this story of why I'm not going to do my homework, and it used Hooke's law. And I thought that was fun, and I played with that for years. And then about 3 years later, I came up with an equation for emotion. And then I, from there, found a calculus framework of emotion space. And then I started playing with like flows in emotion space. And then only recently, like in the last 2 years, I've made progress connecting all these ideas in what I call emotion space to like the science that everybody else knows and loves. And so the fundamental game that I'm playing with connecting all these ideas to all the ideas that everybody else knows and loves is the same one for electricity and magnetism, which is a source, a conductor, and a flow. And in the analogy or the game that I'm playing to connect all my crazy ideas to stuff people know and love, is let's say that knowledge or ideas are like the source. So they're in a domain, which is the source domain. And then let's say that all, and I call it Einsteinian space, which is just a crazy word, but basically all energy, matter, and then space and time are in this other space, because E equals mc squared. You have energy, matter, and then the speed of light is a ratio of distance per time squared. So you have space and time. So it's like, okay, so we have energy, matter, space, and time. That's great, but we don't have ideas. We don't have feelings. We don't have ambitions, capabilities, right? So, okay, so the Einsteins helped us with giving us E equals mc squared. Now I'm just going to say, okay, all that stuff, let's put that all in a domain, a space. I call it real space. And then the last space, the flow space. Oh yeah, and that's the conductor space, right? So I have a space for ideas, a space for all energy, matter, and space and time. And then the third space is emotion space. And to me, that's analogous to the flow space. Yeah, so anyways, so idea space is like the source, real space is like the conductor, and flow space is like emotion space.
That's a really interesting framework, because one of the things I've been trying over the course of 5 years to explain on my channel, I don't talk about it very often because it's such a big idea in my head that I can't break it down in a way to talk about it. But this gives me a sort of a format. Okay, so the idea is the knowledge idea, the idea space is the painting comes into my head. Oh, I want to represent this. And so the idea is there. And then the real space, the energy, matter, space, and time is the time that takes place that's required to get the painting down on the or to, you know, round up all the materials, to figure out how I'm going to approach it, to set up the constraints and the limitations that are going to help me to achieve what I want to achieve, to determine the materials that I'm going to use, to set up the particular palette that I'm going to use, find the brushes, all of these things, a substrate and all of that. That's all in this conductor space, because that's my action that I'm doing.
Yes.
And the flow
Yes.
is the energy that's
Yes.
working in me, that's making all of this fit together in a particular way that is more than what I could do on my own. There's something more that takes place in that process. And all of that something more is because of the original idea. Because the idea is there, the source potential is there. I can see what I need, but I have to keep with the flow. I have to keep always going back to the idea and determining, have I gotten there yet? No, I keep working. Have I gotten? I'm always referring back to that original thought. And yeah, so I kind of think that's the way the universe is built, that structure is the universe. And there's a lot that takes place in that middle section.
Yeah.
But the flow and the source are definitely, yeah, I like that picture.
Yeah. If I could embellish it a little bit,
Yeah.
Or with an imagination. So if you have all emotion space here, and then you have an equals sign, and you put all real space here, this is where your paint brushes and your paints and your oils and your acrylics and your canvas and you and the store, right? All real space here. And then all idea space over here, right? Like all ideas.
Mm-hmm.
And then the relationship is similar to, it looks like multiplication when you write it on paper or a whiteboard, like ideas times the real space equals the emotion space. But okay, so this may be an experiment too difficult, but take all of idea space, sweep all ideas, right? All canvases, all possible paintings that could possibly go on a canvas. Like, look at all those ideas. Now, when you look at, you know, your life, your workshop, your canvas, your paints, you're filtered. You know, you've basically filtered what could possibly, you know, you've filtered to a particular set of emotions, right? All the ideas still exist and all materials still exist, but you just filtered your reality to what's in your workshop. And so you could find ideas that you can't access, but you could find ideas that you could access and then get them on the, anyways. So, so I like to play with visualizing the full space and then filtering down to what's present.
Yes,
I don't know if that helps.
There is a structure that exists in the universe somehow, that it also exists probably in our social domains and our intellectual domains, because it shows up in writing everywhere, but it also shows up just in the lived story of people's lives. And that's something called a chiasm. Are you familiar with the chiasm? So a chiasm is a structure. It's a structure like this. So it looks like an X, but it's where you take a lot of potential and it gets narrowed, 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 and then it has to go through a very tight space. And then when it comes out the other side, it gets wider and wider and wider, right? So the way it works out in writing, and there are quite a few passages in the Bible, in the scriptures, that are built like this, where there'll be an idea, which is called like A. There'll be a line that would be A, and then there's a B line, a C line, a D line, and then E is the center point of the idea. And then there would be D prime, C prime, B prime, A prime. So A prime and A are parallel concepts. B and B prime are parallel concepts. And when you're reading it, you can actually see this happening in the text. But it also happens with people's lives in the text. So the life of Joseph is like that. He starts out the son of a wealthy father. He has all these dreams of his future and everything is great. And then his life gets narrowed, narrowed, narrowed. He gets sold into slavery. He ends up in prison. But when he comes out the other side, his life gets broader and broader and more powerful until he is the second most powerful man in Egypt, and he saves his people. So that chiastic structure takes place in the story verse of our human lives. It takes place in our literature. I think it also takes place in maybe even in electrical engineering. I don't know. I have a suspicion that there are certain structures in electricity and so forth that have that. I mean, when I look at who was that famous physicist? Can't remember, his name just dropped out of my head. In the 50s, 60s, everybody.
Karman? Theodore von Karman?
Feynman.
Okay.
Feynman's little electrical diagrams, they look very chiastic to me. So I mean, I think that shows up in biology, chemistry, it shows up in a lot of places. So I think there are these structures that are sort of built into the universe that you see everywhere. And so this idea of ideas, and so you're saying that there's a great potential number of ideas, a great potential number of materials that could be used. Then what the artist does is I think they have to design constraints and limitations for themselves to get that idea space and material space down to something manageable so that the flow can operate. Because if they don't reduce it down, then you're faced with this infinite field of potential and you can't move forward. You get completely immobilized, right? So there has to be, the way that there's a path through is by bringing it down into something. And in a way, that's kind of the way thought works, because you and I are completely different people because of the life experiences we've had, the education, the friends we've cultivated, the pictures that interested us, maybe the movies we saw, the songs we sang, all of those things built us something into us, so that when a thought comes into us, it goes through that entire filter. And when it comes out, it's something that's idiosyncratic just to me. And you have yours that's just to you. So then when we communicate together, we have to try to rebuild the relationship between our two our two thought palaces. We have to connect that up again so that we have meaning again at the other end.
Interesting. Wow. Okay. All right. Okay. Excellent. This is excellent. So when I was a kid, I'm going to launch into a story,
Yeah.
but it
Okay.
totally will eventually tie back in. So when I was a kid, um, I was on the older end of the spectrum in our family. So when two of my younger brothers one time were having a disagreement in the room across the hall, I always was a thoughtful kind of person. I could put myself in like a meditative state as a young kid. So anyway, so I was in a think, right? I was thinking, and my siblings across the hall were just being little kids, and mom had to get involved. So mom came upstairs, and I hear him over in the other room, and she's trying to figure out what was going on, and how's this, and how do I fix it, and I remember just realizing, if you don't realize what the problem was, you're not going to be able to find the most intelligent solution. You may
Mhm.
be able to solve the worst parts of the problem, but if you don't know what the problem is, you can't solve it, right? And I just drilled that. I think I wrote it down. I just like, if you don't know what the problem is, you can't solve it. And I forget how old I was, but it was a young teen at least, right? And so then fast forward, I'm in my late 20s, and uh, um, so I was talking to a friend and about like a topic that's taboo, and I never talked about it or looked at it as a kid, but it was the topic of astrology, and it's like, okay, what, and um, and so first of all, there's no scientific basis for astrology at all. But what him and I were talking about, he's like, yeah, that's actually like the fundamental story in astrology. And I was like, what, And but basically baked into maybe this is not a good way to go about it, but um, so so basically the story him and I were talking about is basically it's an analysis of like it's a story about human culture and society and individuals' personalities and how we relate to each other and how we can fail and negatively impact each other. But it's also a story. The story I'm about to like try to recreate is also about trying to not fail and trying to um, not hurt people the way we've been hurt. Um, and so um, the way the story goes is um, it's a 12 generational story. Each generation has a unique strength, right? They have a unique strength that they're very good at, and it's a very valuable strength. It's all positive, right? Like each generation has a strength, um, and they live out the fullest potential of their strength, or at least they try to. Um, but the strength has weaknesses, and those weaknesses negatively impact different people. But the people that will feel it the most are the children, right? The children always feel it the most. So, the way that the story is encoded to make sure that you went from one generation to the next, it always transitions from a father to a daughter, and then the daughter will grow up and be a mother to a son, and then the son will grow up and be a father to a daughter, right? So it transitions gender at each generation. Um, and just the way that they drew it many years ago, I don't think there's anything um, say special about the story other than it's just an interesting story, the way that it's designed. But the way that they drew it is the first six generations, all of the strengths and failures are focused at the individual level, and the second six are focused at the cultural or group level. Um, and um, and which those are kind of opposites right there, individual versus group, right? So you have kind of a binary opposition right there. but then each generation, if you go directly across the cycle to what's on the opposite side of the cycle, they have an opposite strength and an opposite weakness, right? Like with what this one is known for, that one's known for the opposite. So anyways, so it's the story, and once you kind of know the pattern or the program of the story, you can just recreate it, knowing the very beginning. And so the very beginning is being strong at expressing yourself, right? Who am I? Answering that question, right? That's the strength of the first father, right? Is it's an expression of yourself. And so that's what the very first generation is really good at. It's I am this, I am, right? This is who I am. This is what I'm about. This is what I like. This is what I care for. This is who I take care of, right? It's about exerting yourself. The weakness with that is you are what, right? Like where are you, right? Yeah, so you are, like the child complaining about the daughter complaining about the father. Yeah, you are big and important, but like what's going on around you? You're all focused on yourself. And so the daughter improves on the father's shortcoming of not being fully aware of the surroundings, just being aware of himself. And so she knows her environment. She knows where she is. I am here. I'm right here, right? I'm not going to make that same mistake of running around, smashing into things accidentally. I'm right here. I'm in the middle of a field, right? And I'm not going to move. And then the son for that mother, right? His mother was so stubborn, she would never move, right? So the son is able to consider options. He's able to go, it's not so much about just being in one place. It's about being able to consider possibilities and go take the better possibility. You have to be able to move. And so then the daughter to that son, what she felt most from her father was he never cared, right? So he was always able to consider the options and pick the best option, but he never really cared. So that daughter grows up and is incredibly caring, nurtures everyone around her, like a nurse or a teacher. Maybe not a teacher, more like a nurse. But anyways, just very nurturing, very caring. The problem with that, the son notices, is that, hey, mom was the doormat, right? Like everybody just, kind of. So anyways, you can kind of see how you go through the generations. And by the time you get to the last generation, what the last generation is very good at is understanding the group and understanding the individuals, because each generation doesn't forget what the previous generation learned. They benefit from all the learning until you get to the end of the cycle, where they benefit from all the learning, but the shortcoming of the last is that they forget who they are, right? They understand everybody else so well, they don't know who they really are. And so their shortcoming is they don't exert themselves. Like, who are you? Who am I? And so that's what their child fixes, and it starts the cycle over. And so there's this story of this kind of 12-step cycle, which is a story about human culture, human society, personalities, the way that you have different roles that interact with each other to make everything work. And I don't know how old the story is. Like, I can see the stories there. Somebody else thought of it a long time before me, but I've never really heard anybody else talk about it.
So just to clarify, this is the story that you see in the 12 astrological signs?
Yeah, maybe astrological signs is, I wouldn't use that, but yes, yeah, basically. So when you look at the kind of the stories that are around the taboo topic of astrology. You see this underlying story.
I see. Okay. Yeah, because I've never
And
looked at the
it's got
taboo. I've never looked at the taboo. So,
well, the way I was raised, it was all kind of taboo. I know in Genesis on day 4, right? God created the stars for signs and seasons, and
mhm,
and I know that when Jesus was born, there was an astrological indication that
mhm.
wise men were able to pick up on. Um, but but you
Well,
know,
and most recently, I had several conversations with Wolfgang Smith, who's a very prominent philosopher, physicist, mathematician, who's also a really dedicated Catholic and very knowledgeable in theology. And he seems to think that there is something in astrology that's meaningful. So I didn't have an opportunity to delve into that with him, but I have a number of his books, so I'm going to take a look and see if I can run across something that he says about that, because
I'm not familiar with I'm not familiar with anything in astrology that I would use with a level of confidence when designing either an electrical, a mechanical,
yeah,
or a
yeah,
chemical type
for
of thing.
sure. Yeah.
Um, so as an engineer, I'm not sure if there's anything that's useful for me there as an engineer, but as a thinker or someone that just enjoys, um, how do you take a story? How do you take something that you see so clearly and encode it in a story that
Mhm.
can be told and retold again and again and again, and the story won't be lost? Well, to do
Mhm.
that, you have to create a pattern. You have to create a program. You have to create a main storyline that's interesting enough for it to be passed down by someone who's less interested and less able than perhaps yourself. Um, and so
Yeah,
I've
that's
seen
really good. That's really rich. Yeah.
So I see that there. I think this main story of generational improvement, every generation is trying to do the best they can and solve the problems that came before them, but they're gonna succeed. They're not gonna make the same mistakes that their parent made, but you're gonna make your own mistakes. And your mistakes are gonna affect your children, and they're gonna do the same thing you're doing. They're gonna try and do their best with what they have, where they're at, but they're going to make mistakes, and it's going to affect the next generation. And it's going to always, this is a cycle that's always going to continue as long as the stories continue.
Mhm.
So, um, yeah. But so I'm not sure how much is in the astrology books that's actually useful. But there is this underlying story that that everything kind of builds around. Um, uh, and the other thing is, I mean, today we can pull out a pen and pull out a notebook and write something down. But if we go back not that far, you could be hundreds of miles away or hundreds of miles and hundreds of years away from a pen and a paper and have a great story. How do you pass that story down?
Mhm.
If you're hundreds of miles away from a pen and paper and you want to pass a story down, you have to find a program, you have to find a pattern to encode it in.
Mhm.
Um,
Well, and that's the other thing that I think you see in astrology is that they looked into the night sky and they made stories out of those stars so that they could um, encode the pattern that they saw. They could tell a story about the pattern that they saw, so that maybe sometimes those things in the sky don't move that fast, but it might be generations before some part of it moves. And then when that happens, people had a pattern to go by. Well, this is what it looked like 300 years ago, and now this is what it looks like. So they had to find the pattern, and then they tell a story about the pattern because that preserves the pattern for the next generation and the generation after that, right? And I always thought they must have amazing imaginations, because when I look at those stars, I don't see those patterns that they saw. You know, the only one that I can really clearly see the Dipper, the Little Dipper and the Big Dipper. Yeah, I can see that, and I can see the belt of Orion. Yeah, that looks like a belt.
Yeah,
but the rest of it, I'm like, that does not look like a lion. That does not look like a lady, you know.
So, so, so here's one way I've used astrology to answer a question, a philosophical question that may already have an answer that satisfied people. I'm pretty sure questions get pushed around longer than the answers, you know, even after answers are satisfactorily given. But so there's the question, I don't know who's posing it even, but let's say you're the conductor of a train and you control the switch to take it to a different track, or let's say you're the observer of a train controlling a switch to divert it to a different track. And let's say, you know, both tracks have a bad outcome. So either track it goes down, you know, bad outcome is going to happen. What do you do with the switch, right? You're in control. And the way astrology has helped me solve the problem, right? No, just like the story, like transforming to a story domain and playing with it over there and then coming back, is Sagittarius is the half horse, half human archer, right? And Sagittarius is the generation or the character in the story, which is most interested in truth seeking, and truth seeking at the group or the culture level. So truth seeking not just internally, but like at the group level. And it's an archer, so he's about to shoot an arrow, or that's what he does. He shoots arrows. And so the solution as an engineer, thinking about like a self-driving car that has to make a bad decision, right? The solution is basically Sagittarian, which is you fire out threat messages, right? So you send out a threat of like, hey, I'm a big train, I'm headed your way, do you want me to come down this track? And you listen for a beg. So you send a threat and you listen for a beg, both directions, and you've got all your observations from both directions. If you only get a beg from one direction and you're programmed compassionately and you don't observe an unannounced beg, you go the way that it hasn't been begged against, right? It's a form of truth seeking. It's very Sagittarian, but yeah. Anyways, but yeah. So that's one way that maybe learning the stories of astrology can help you transform to a different story domain and then come back and solve just the engineering problem. Okay, how are we going to code this? All right, well, let's code in a threat, beg, you know, compassion equation into our decision matrix. And it's just as simple as that.
Now, with you working on integrated circuits, you're working at the hardware level, right? So you don't run into those kinds of
so I design circuits that go on the printed circuit boards, and last year and early this year, I designed a control board for an air conditioner. So if you go to a hotel room, there may be an electronics board in the air conditioner that brought it to life, right?
Mm-hmm.
So when you push the button or you touch the wall stat, you know, some electrons may, if it's the one I did, some electrons will be flowing through copper that I drew.
Mm-hmm.
And for the month or two that I was designing the board, like in earnest, like that was the design stage I was at, I would basically wake up in like a REM sleep every day and kind of go over the board and then find things that needed to change. That's just the way that good design engineers work.
Mm-hmm.
So yeah, anyways, so I basically design boards and circuits and capture schematics, and it's about to be obsolete. Check this out. So before the end of my career, I won't be drawing copper, right? I won't be drawing schematics. I'll be interacting with an AI-enabled CAD tool, and I'll describe at kind of a higher level what I'm looking at, and the schematic will be captured, and the layout will be, the components will be oriented a certain way, and then I'll basically be, yes, I like that. Yes, I like that. Yes, this is good. No, not that. This needs to change
Do
like
you
this.
have a high level of confidence that's the way it's going to work? I mean,
Oh,
like
absolutely.
when you wake up in your REM sleep and you're picturing this board,
Yes.
you have a relationship with the materials, basically, because you know what the materials can do, you know what your end goal is, and you know what you need to get there, and that's all processing inside your head. And if you say to an AI, this is the outcome I want, do you have a high degree of certainty that it will find the best path for that outcome?
So here's so yes, but I'll tell the story a different way. So to make the control boards that I made, it took me a couple months of my life because I had to do a bunch of stuff. It was kind of a brand new design. A lot of the CAD files, like I had to create a whole set of libraries, like part libraries for the board. So it was very involved. I would say that there was probably 10 million clicks, right? So every design project that an engineer does, you could count the clicks of the mouse, right? Click, 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 or keystrokes, click, click, click. And it's probably, I don't know, 10 million clicks.
Mm-hmm.
And I had to click every one of them, right? I had to do every drag, every click, every keystroke. And so I think within 10 years, a lot of the work that's being required or being done by design engineers is going to be automated by AI. So yeah, so there's a lot of work that will kind of just disappear. Yeah. So anyways, I'm trying not to use my equations to describe stuff too much, but
I don't mind. I don't mind. I like your equation.
So basically, force is ability times ambition, and AI.
Is that the spring one? Is that your spring? Yes. Okay.
Yes. Yeah. So force is ability times ambition. That's analogous to the spring. But ability, if you give me a CAD tool, then I'm able to use this CAD tool. And if it takes 10 million clicks, I'm only able to do it if I do the 10 million clicks, right? Now, if you give me an AI-enabled CAD tool, and I can do it with 100 clicks in an afternoon. Now you've just given me a nonlinear increase in my ability function. If my ambition is 0, it has no effect on my force that I can exert. But if my ambition was definitely not 0, it was high. I wanted to do a lot of stuff. I wanted to build this, I wanted to build that, I wanted to see this, I wanted to do that, right? Then you just gave me a nonlinear increase in my ability function. That's a nonlinear increase in my force function that I can exert.
Well, I guess the thing that I wonder about, I mean, I have no idea because I don't really understand exactly how AI works, and I don't understand how what you're doing works, but I do think about time as an element here. And because it took you 2 months, you developed new thoughts and new ideas that made it a more beautiful and robust outcome than it would have been if you had done it that first afternoon. So even if you can sit down with an AI-enabled CAD in an afternoon and say, this is what we need, because that time element hasn't taken place, it's really just a rough approximation of your first go at it. Even if the
Right.
AI can do the details appropriately, it may not end up being the beautiful thing that you created over a 2-month period of pondering. Do you see what I'm saying?
Yes, yes, yes. I see what you're saying. The there's it's a very rich, that's a very rich connection to the topic. So just to create a separation, or an artificial separation for a moment, and I say artificial because I'm both an artist and engineer. So as an engineer, taking off the artist hat, the way engineering works is that's okay, right? It's okay to go with something that an AI generates and you didn't have an artist lovingly draw. So it's okay to do that. And then as the artist, it's like giving me a different paintbrush. It's like giving me a different medium to express the art in. Because today, I receive a paycheck and I pay for the roof over my head, the shed in my backyard, the beer I drink, based on my ability to draw one click at a time, one line at a time, or one group of lines at a time. What eventually becomes copper on a fiberglass board, where chips get soldered to it, right? But in the future, there will be a different tool that artists use at a different level. The tool will still be drawing copper on a board the way that the artist wants it, but it's going to be at a different level. Here's the story. Here's the exciting story to kind of think about in this. So the very first chip that I learned was the 555 timer. It was the first circuit that I breadboarded. It's a little small 8-pin chip that puts out a square wave, right? So you can make an LED blink on and off. It's not crazy impressive, but it's actually the first thing that a lot of people learn when they are starting to learn electrical engineering. And that chip was designed by an electrical engineer who he was out in Silicon Valley. He had just gotten hired at a big company, but they lost some government contracts, and so they laid off half of their engineers. he was still there, but morale was really low. He wanted to go write a book, but he needed to pay for life, right? He had he was married with, I think, 3 kids or 1 kid. I don't know. He had kids. And so he told the marketing guy, hey, I kind of want to make this chip, right? I want to do it from home. I want to make this chip. I want to write my book at the same time. And by the way, he wrote an excellent book. It's free as a PDF on basically a short synopsis or bio of the scientists and engineers behind electricity and magnetism. So anyways, that was one of the books he wrote. But
so when we're done talking, send me the name of that book and the author, and I'll put it in the information section.
Yeah, Hans Kamenzind. But anyways, I'll send it to you for sure. So the marketing guy, according to Hans Kamenzind, the marketing guy had a workbench at home and he would solder electronics. So he described the chip that he wanted to make to the marketing guy. And the marketing guy was like, yeah, that's a good idea. Go ahead and let's do that. So the marketing guy greenlit, the marketing guy said, let's do it on what would become most electrical engineers' entry point to circuits, which is kind of crazy, right? That this chip kind of just happened in this chaotic, layoffs. I got to find something else. I want to do this other thing, right? So anyways, so they paid him. He designed it at home on paper, right? He designed it on paper. It worked the first time, right? Just like crazy. And then he went on and he started a company. He had like a 30-person company, the engineer did, doing something else with different chips, right? Like that chip, he never made money from that chip really. And then later he sold his company, and later in his life, he passed away in 2012. But later in his life, he told his son that I'm now with CAD, because he designed that chip on paper. And then he had a whole company that was on paper. And then CAD tools came out, and he told his son, I'm doing more with CAD than my entire 30-person company did. And nobody seems to have really talked. I don't know if CAD got the same hype that AI is getting, but we're about to go from non-AI enabled CAD tools to AI enabled CAD tools. And it's going to be for a couple people, it will be like, I used to have a 30-person company. Now I do more just on my own. So we already experienced that in recent memory, and we're going to experience it in the next 10 years again, with engineers getting their hands on AI-enabled CAD tools.
Well, it's wonderful to talk with someone like you who has such a positive, uplifting outlook about it. So that's really good.
Oh, yeah. No, I'm super excited.
Yeah. Yeah. Well, this has been a great conversation, Nolan, and I hope we can do this again, because I'd like to hear more about your art.
Yeah.
So
we'll have to save it for the next time, but I only have one or two oil paintings. Is that one of your pieces back there? Yeah, should I grab it? Yeah. So in 2016, I called up one of my sisters and I said, hey, she's the artist in the family. And I said, hey, let's do something. And, so I bought a bottle of wine and some painting supplies, and then we got together, and so this was the one I did, but
that's the first thing
I started doing it. Say it again.
That's the first thing you ever did?
I think it was number 5 or 6. So I'd already practiced before. But what was unique about this one was I was doing the brushing, right? And I couldn't get it. It wasn't coming out, right? Oil, it's hard to get. And so it was on this. It was on this right down here where I started playing with, I started kind of mixing it on the canvas. And then a kid that lived in the apartment above mine saw me painting on it while he was walking past, and so we were talking about it and this and that. And he was like, "That's called stippling, right? Where
Oh,
you kind of do the So I
uh-huh,
didn't even know the name of the stuff, so I had to reinvent stippling.
uh-huh.
But yeah, so that was yeah. So and I forget names. The last artist that you had on,
Josh Thiessen.
yeah, the picture of the beach driftwood,
Uh-huh.
the painting of the beach driftwood, the contrast on the wood. One of the things about this that I've always been, well, not always, but like less satisfied with was there's actually in the photograph more contrast
Mhm.
on the center of the flower. And when I was painting it, I had it there and I just got less confident. And so I made it more even. And I've
Mhm.
always felt like if only I'd have been more bold to explore the contrast in the flower. Um,
Well, when
so,
I first
anyways,
started painting, I did watercolors, and I was walking through a like an art fair or something with my daughter and my son-in-law, and I saw a picture of this older home. It was a painting of an older home with a flag hanging out front, but it had really deep, rich shadows and really brilliant light coming in. And I said, man, I wish I had the courage to paint like that. And they said, well, why don't you? And I said, well, it's very easy to make mistakes with watercolor, and paper is so expensive. Because a piece of watercolor paper is like $10, which to me at
wow.
that time seemed like a lot of money. And my son-in-law said,
Yeah.
I'm going to buy you 10 pieces of paper. Just do whatever you feel like. It's just paper. And that really was kind of what started opening some doors where I started to think, oh, I could be more courageous.
hmm hmm
So
Uh,
it's really hard once you have a painting and then you kind of like it, and then you think, but what if I screw it up by doing this? So
yeah.
you kind of have to have this. It's perfectly okay if it gets messed up. It's just a painting.
Right.
More where that came from. You know,
Right.
there's a lot of stuff in your head that's one of the fascinating things I think about what you're doing, like what they do in Silicon Valley, is where information becomes physical. You have this picture in your head, and then it becomes copper wire on a piece of fiberglass, right? It's just,
Mhm.
it starts out as an idea, and then it becomes something that fits into something else that makes this computer I'm looking at, or makes the air conditioner or whatever. These ideas turn into physical things in our world. And that's why it's not hard for me to imagine that the world was created, because there was an idea in the mind of God, and then this world just came out of that. So, but that's another
Mhm.
story for another time. So,
Yeah. Yeah. Can I close with one kind of open-ended thing?
sure. Yeah, absolutely.
Okay, or at least that'll be the last thing I have. I want to get it out though. So when I was painting on this, I came up with the idea, and I told my sister at the time, like, hey, what if I make a CNC, like a 3D printer, but instead of 3D printing plastic, it would paint, like
Mhm,
basically a machine to do the oil painting.
mhm,
And then I could have a computer program where I upload a picture, and it would give me different renditions or versions
mhm,
of ways it could paint it. And all of the strokes would have to be stuff I've trained the machine to be able to do,
mhm,
right? Like I would have to create the whole machine, all the little joints and actuators, and how it's going to grab the brush,
mhm,
and where it would put the paints, and how it would mix them, and how it would sense color, and how it would sense depth. And so as an engineer, I'd have to make all that. To me, that's art.
mhm,
And then when the machine would create a painting, that's art. Um, so maybe one day after I win the lottery the second time, you know, not the first time, but the second time, I'll try and build that machine. So maybe one day I'll have that machine and I can show you. But my sister was like, that kind of takes the art out of it. And I thought about that and I was like, no, I think it makes it squared, right? Like art times art, where the machine is art and then the painting on canvas is also art. So it's like art squared. And I think if I think meditating on that kind of relationship of the engineer, the machine, and the canvas helps answer a question that comes up in my equations of like, what is the multiplication? So if you say flow equals conductivity times potential, like what do we mean by times, right? To me, it's a productive evaluation. And the best like story to help people sort of see that would be the machine and the canvas, like art squared. So it's art times art. But yeah, maybe that was one story too far.
No. I mean, I'm going to ponder that, and maybe we can talk about that next time we get together, because part of me agrees with you, because I do think that even like coding is an art, and I think what you do in building these circuits is an art. But part of me agrees with your sister that if you put the machine in between, but there is this other thing, that there's a potential there that by putting the machine in between, you've added another layer of anomaly. And I think anomaly is what separates photography from what's called fine arts, because once the hand of the artist gets involved, there's opportunity for imperfections, and those imperfections add to the beauty of the art. And so if you integrate a machine in between there, that creates another layer with a potential for anomaly, because there could be little waves in the way that the machine arm moves that's different than a human arm would move, or something like that, that would create another level of imperfection that might add to the final result.
Right. Did you know that every typewriter, the keys were all unique? You could get out a microscope and see a unique like defect on a key. And then in like World War II, they would use that to be able to see where the letter came from, you know? Absolutely.
Because of the idiosyncratic nature of each person's pounding on the keys. Well, even just in the way the key is built in the first place, but then damage that's done through different impress of the people's hands and so forth.
And that effect on the canvas. Interesting. Wow,
so
so much.
Fascinating talking, Nolan. So let me know what you're thinking in the future, and we'll try to put another one of these together.
Okay. All right. Thank you, Karen.
Okay. Thank you.
I really enjoy getting to know you.
I enjoyed getting to know you too very much. Okay. Have a great day.
All right. Bye.